understand this. You now when you're doing vectors, right? Basic result, usually there are two main characters. So in this case, it's A and B. So everything can be expressed as A and B. The area under graph, the area of triangle, the plane equation, and so whatnot. They are all can be expressed in the form of A plus B, because it's just like in Cartesian diagram. Imagine that in secondary school, right, when you're doing Cartesian form, or I mean even now you use Cartesian form, right? You can express everything in terms. If I draw a triangle here, you can find the area here. You can even find an equation for x and y. The rationale is because you can mix and match x and y to achieve whatever you want. So it's the same thing. Instead of having the axes as x and y, right, you can have a and b like that. So now you have sort of like a slanted axis. Okay, just remember that. So in vectors, right, when we write in a and b, essentially we are saying it's like a Cartesian coordinate but slanted axis. So that's the main thing. So don't get too worried about it. So just now, one of you mentioned that it looks like a plane equation. It's correct. It's actually a plane equation. So r is 0, 0, 0 plus lambda. You can just add a 0, 0 here. Why? Because this is okay. This represents all the points on the plane which passes through the origin. Okay. And the plane have to remember, so it's the same thing. You take a point, this is a point, you add a dimension, it becomes a line, right? So this is a line. They add another dimension, it becomes a plane. So this is a plane. And parallel to vectors A and B. But the important thing is where A is not parallel to B. A. So since C is on the plane, since C is on the plane, OA B, or you can write coplanar. The 1 mark is for the coplanar. So hence C is equals to, for some, C is equals to lambda A for some lambda mu real value. Okay. 1 mark, you don't need to write everything here, but this is as precise as you can get already. So I write down everything that I think is required.